Hi, this is Dave Johnson with another edition of Math Off Topics. Today I want to talk about slack variables and inequalities. Now, you'll usually find those two topics together in a course on linear programming or optimization theory, but I think that slack variables can be used to understand inequalities a lot better. And so that might be useful for college algebra students, even high school algebra students, and certainly even calculus students. So let's get into it. So, what I want to talk about today is the property that if you have an inequality, let's say a less than b, then if you multiply both sides of the inequality by some number c, then if c is positive, then C times A is less than C times B. In other words, the direction of the inequality doesn't change. And I don't like using the word flip the inequality, although a lot of people do, and people will know what you mean when you say that. But I want to be clearer. So when you multiply both sides of an inequality by a positive number, then the direction of the inequality does not change. And this is going to be true whether it's a less than or whether you're starting with a greater than. On the other hand, if your c, the number that you're multiplying both sides by, is less than zero, if it's negative, then you have to change the direction of the inequality. So less than becomes greater than. Or if this were to be greater than, then greater than would become less than. Now, usually when teachers tell you this, they say, well, it's true, or they show you a couple of examples, but I'd like to show you why this has to be true. And so let's just do a very simple derivation here. So want to make this distance s, and we're going to say that s is greater than zero. Okay, and s is going to be our slack variable. And if a is less than b, in other words, if a is to the left of the number line, or left of b on the number line, or what I'm labeling here as the x-axis, then if a is less than b, then we can change that into an equation. So a less than b is the same as a plus s is equal to b for some value of s. And we don't know what s is usually, nor do we care in this case. All we really want to know is that a is less than b. And if that's the case, then s has to be positive. Okay. Well, it's so much easier to work with equations than it is to work with inequalities. We know a lot of facts about equations. We've worked with equations all of our mathematical lives, whereas inequalities can be a little weird. Okay, and you have these different rules. And so, well, let's take our equation. So a plus s equals to b. And now let's multiply both sides by c. And let's say c is greater than zero. So if we multiply both sides by c, we get c times a plus s is equal to c times b. Distribute, we get c times a plus c times s is equal to c times b. But notice that here we have an equation. We have CA here, CB on the other side of the equation, but we have this CS, which you can think of as a new slack variable. If C is greater than zero and S is greater than zero, then C times S has to be greater than zero. And if C times S is greater than zero, then we can conclude that CA has to be less than CB. So we didn't have to use specific examples. We didn't have to draw graphs to do this, although I used a graph to define S. But now we are able to say that if C is greater than zero, then CA is less than CB. Okay, well, let's do it the other way. Let's say C is less than zero. So we start with our original equation, a plus s equals b. We multiply both sides, we get c times a plus b, or a plus s is equal to c times b. Just like we did before, we distribute c times a plus c times s is equal to c times b. Okay. But now we have something which is less than zero times something which is greater than zero. So c is less than zero, s is greater than zero. Negative times positive is negative. So if I mark this as less than zero, then in order to get the proper result as an inequality, this less than zero CS would mean that CA has to be greater than CB. Because if you subtract something from something that's greater, you get something that's smaller. So what we've just shown is that if you start with A less than B and you multiply both sides by something which is positive, you don't change the direction of the inequality. Whereas if you multiply by something that's negative, then you do change the direction of the inequality. And you can repeat this derivation proof, if you like to call it that, for the case when it's greater than, the same result will occur. So I hope you've enjoyed this video. Hope it's been helpful. If so, please like and subscribe, and I will see you in the next video.